So for the next one, like this is just I have like this was when I was explaining. So I have modified it. So now this is our y-axis, this is our x-axis, and this is called the vertex. This is the directrix. This is the parallel line, just indicating the y-axis for easy notification, like for clarification. Then sorry this is the axis that is perpendicular to the that is perpendicular to the directrix, and it's symmetrical at this point, and it passes through the focus. This is the focus. So like now want to get the form, like equation of the parabola, because there are different equation of parabolas, like at different, like different type of parabolas have different equation. So this type of parabola is it's facing the x-axis, that is the positive side. So this is the focus. Now we are going to take a point on the parabola. We are going to take a point on the parabola. We take it at the upper side of parabola. So just take any point on this parabola. We take this point here, and we label it P. We don't know the coordinates, so we label it X, and we label here Y. So now from this point, you join this point to the focus. This point to the focus, you join. Then from here, you join it to the directrix. You join to the directrix. So you join this point to the focus, you join to the directrix. This point on the focus is parallel, like the line join the P, like PF line, the line PF is parallel to the line DP. So the line PF is parallel to the line DP. So what we want to do now, I want to get the equation of the parabola. Now understand, from this focus is on the x-axis. This focus is on the x-axis, and it's on the positive side of the x-axis. If you look, this is our y coordinates. Like this is our y, yes, this is our y-axis, sorry. Then this is our x-axis, and it's at the positive side. If you go back now, this is our negative x-axis, and this is our negative y-axis at down. So this is our positive y-axis, this is our positive x-axis. The parabola is facing here. So now we want to find the coordinate of the focus. Let's take first, like from here from the directrix to this parallel line that is drawn at the vertex, let's take it as A. Let's call it A. So this line from this focus to the y-axis is A, and it's equal to, like, I don't even know, let me see the line from this focus to this point, the vertex, are equal. So from a focus to a vertex, from the focus to a vertex is A, then the vertex to the directrix will be also A, because they are always equal. They are equal. Don't mind my drawing, they are equal. So from this focus to the vertex is A, then from the vertex to the directrix is also A, but just that this A will be in the negative form, since it's falling at the back side, at the negative x-axis. So here is going to be the negative form. We are looking for the focus. So the focus, this point is the origin. This point that we call the vertex, if you look at it, is the origin. This is negative x, this is positive x. It's just like our normal graph. This is the origin. So the coordinate of f will be A, since it's the distance of the x-axis. Then this O will be for the y. So x has a coordinate of A, y has a coordinate of 0. We have found the coordinate, and we know that if we want to find D, so where this line, since we join P and F, we join where this line here joins to this directrix, the point, we call it D. So now we have to find the coordinate of D. So we know that this is the y-axis, abi. We know this is the y-axis. So the value of y here must be equal to the value of y, since this d2, if you want to read the value of y, it's going to be the same thing here. If you want to read the value of y, it's going to be the same thing. So we have gotten that the coordinate of y for d, it must be equal. So see now, it is equal. So now we are going to look for the coordinate of x now. So since the coordinate of x, I said since from here to here, from the focus to the directrix, from the focus to the vertex is a, so from the vertex to the directrix is also a, because they are equal. So now if you want to read what to be the coordinate of x here, is going to be minus a. Why? Because this equal a is falling at the negative x-axis. It's falling at the negative x-axis of the, let me say, the graph. It's falling at the negative x-axis. So that means we have gotten our coordinate to be minus a. So now we know the value of d, we know the value of p, we know the coordinate of d, we know the coordinate of point p, and we know the coordinate of point f. Now we have to solve using our distance formula. We know, I said earlier, that dp, that is the line dp, is parallel to the line pf. That means they are equal. So that means dp will be equal to pf. So we are using our distance formula so that we can get the equation of this parabola. So now when we use the distance formula, we have like dp is equals to distance, this d means distance pf is equals to distance dp. So using our distance formula, we have that y square minus y1 all square plus x square minus x1 all square. We have the square root. So then y2 will be for like this y2, we start from this point p, x2 will be in this point p, because that is the, let me say, it is sovereign point. So that means for line pd or line dp, y2 will be this point, this coordinate that we don't know. Then the y1 will be here. So substituting into the the distance formula for the first one, we have, when we do it, we have, this is the end result. That means y minus 0 is still the same thing as y, then square, then this. So we do for the second one pf, we still get the same thing. So we did pf, this is going to, it's still the same method. Pf, y2 will still be this, x2 will still be this, but the focus here will now be y1, x1. So you repeat the same method for dp. Then you equate it, because I said they are equal. So you have something like this, dp, see it, dp, since dp, that is the distance, pf is equal to the distance dp, you equate it. Then you might like, you don't understand what I did here. So when you equate it, you have something like this, x minus a square plus y square is equals to square root of x plus a square. Then you have to take the square root of both sides, so this will cancel out. Take the square root of both sides, so that's how I got this one. So using algebraic expansion states that when you have two numbers a minus b all square, it's going to be a square plus this a square minus this 2 will come down, 2 minus 2ab, then plus minus b square. So it's going to be a square minus 2ab plus b square. So that is how we got this one. We simplify from this one, so it's now going to be plus y square. It's going to be equals to this one. Yeah, it's going to be equals to this one here. So when you do the simplification, you will get this one. Like it will be simplified to the lowest term as this. So then y square will now be equals to 2ax. Bringing this one over, you are going to have plus 2ax. So y square equals to 4ax. That is the first equation for this type of parabola.